Hello everyone, so we've just built our LayerNorm forward pass, and today I'm going to integrate this with my existing code, and this will be having lots of different issues. I need to debug them all on this live coding session, and let's see what I can do now. So I'll be integrating this with our main code, main script. I'll be creating a dedicated LayerNorm class or structure with the forward pass, and I'll be like integrating with my existing code, and let's see how it goes. So it's going to be a messy session. Fingers crossed to me. All right, so where we are, yeah, so which branch we are in, Autograd, that's fine. Alright, so where's main.c, and let's just first fix this. So we've written all the functions over here. I need to just copy them all, yeah, starting from here to here, right? ln.c, something is wrong, rm.swap file, ln.c, and we have a forward method over here, and yeah, so we've written all the rules over here which we have just done, and let's just integrate it now. So I'm gonna just do this, and then okay, delete this entire thing. All right, so what we got over here, so arena, yeah, layer norm and x. Tensor X should not be here, I guess. Okay, so what if I just delete this thing? Alright, so layer norm edge. What does the header, how it is defined? So layer norm, yeah, so we need to change these things. It doesn't take two tensor, it only takes one tensor for now. And ln.c forward. Okay. Yeah, I need to paste PyTorch link over here. What is X? So you can ask me, what is X? So let's just see what this X is at the first place. So main.c, layer norm, where have we called it? Create initialize parameters, create new, yeah, and yeah, there it is. There's the forward pass, and it should take attention is score, and this L1. Attention score is Rx, and what is L1? So it is updating something in the structure itself. So yeah, so let's just see the structure, because it's taking, this is Rx attention score coming from multi-head attention layer, and then we have L1 as well. So it's just doing something. Something means that it's just, you know, changing some structure as well, and it might be populating some extra variables or words. So let's just see. Layer norm edge, it has beta, it has gamma, and it has x hat, right? Fine. So ln.c forward, and we have we need to pass this as well. So layer norm L1 maybe, and mean expand columns. I have to see how the previous function was, because I just deleted that. So let me pull up my repo, where I can see in main as well if I switch the branch. Yeah, so get branch origin. Alright, so get branch and feature batch training. So get switch to um, oh, Okay, so I need to stash the changes. Okay, let's not take risks because we always have lots of issues with git conflicts. And let me just see the code from here. This is my main branch, and if I see the main file, not main actually, ln.c. Yeah, right here, right here. Let me pull up it over here so you can also see. So it would look like something this. Uh, Forward, yeah, and yes. So we have all these things. Variable x hat, right, and then yeah, and then yeah, we need to replace all these things. All I need to see is where actually am I making changes with this layer norm. I have this is coming from multi-layer attention, makes sense. What I'm doing with these things, right? So I'm creating var variance, and okay, yeah, sure. So instead of just allocating memory, I've done what actually I needed to do. So maybe uh, ln.c. So I need to do something like this: forward, and this is my forward, ln var, set this, and what else? Um, x hat. Okay, I can also save this, ln x hat, set this as well, and what else? Output. Are we storing this? Let's just see. Okay, we don't want to loop because we have this tensor now. We have this tensor now in the form of like this. So variance is, this is our variance. I have this entire tensor. I cannot actually, I don't want to like loop through. All I can do is just, I can save it. Okay, let's see what else. Okay, let's do it step by step. So let's say, let's call this ln. Forget about L1. This is ln. Let's say in ln var would be var tensor. That's right. That's right. And what is x hat? Ah, yes. Yes. So what should be the x hat? This out is actually the x hat. Yeah. So ln x hat equals out. And let's see if it works. And what else do we have? ln x hat done. Variance done. We've created the output. We went through row, column. Um, okay. And what else? So we have gamma, we have x hat, and we have beta. So x hat, we've already done this. Yes. So we've saved these two things. And now we need actual y, that is y, alpha times x hat plus beta. Now there are two operations going on. One is tensor addition and the other one is tensor matmul. Yeah. So we haven't initialized y. So y is going to be something like this. Y would be tensor. Y is going to be let's just call it like y shape, and y shape would be what? Man, arena, allocate arena, and n dimension times size of integer, and we have ndim equals x ndim. We have int calls equals to x shape 1, and we have rows equals to x shape 0. Makes sense? All right. Now we have y, and y is going to be tensor create new, and it takes arena, it takes ndim, it takes y shape. Perfect. And we have an initialized y shape over here, so y shape 0 going to be rows, and 1 going to be columns. So we need to have exact same size and shape as input, right? And this should work now. And x mean now what the y will look like. Forward, LayerNorm forward. Okay, fine. And yeah, that's correct. And y is going to be what? Okay, so our y would be ln alpha, or what this is, gamma. No, this is not like this. So I guess tensor matml forward, and I have ln gamma times x hat, which is out, plus tensor add what? Ln beta. Alright, so this is what we need to do, and then we will be returning y. Return y, and let's just copy this entire thing from here to where? Let's just bring them all here. Right. Okay. Alright, fine. Okay, so tensor matml forward. Tensor matml forward. Let's see, does it create a computational graph or not? So, yeah. Tensor. Let's see. Tensor matml forward. So it takes tensor A and tensor B, and it just does all these things, and yeah. Okay. Yeah, everything is fine. So this function works fine. We've already tested this, and let's just go back to this ln forward method, and what we have here is, and do we have tensor addition as well? Tensor and tensor add. Yeah, and it keeps track of everything, the parents, the operations, and everything, and it just returns the sum of these tensors. Perfect. ln.c. All right. Now we need to test this, and okay, and then gamma and out. This will take the product, and then it will just sum both these things, right? And let's just try it out now. So what we have here is, let's just uncomment this entire thing. And so okay, can we test in tensor file, because we already uh, did the necessary stuff over here. um, and let's just now import LayerNorm. Do we have it? No, we haven't. Okay, so include LayerNorm.h arena. Attention, is it a test file or what? It's a tensor file, I guess. Mm, okay, and LayerNorm would be ln1 is equals to LayerNorm create new. It takes arena, and then what else does it take? Arena and features, and for features, what do we have here? Okay, fine. Tensor, and 32, let's say, and 30 features, and now on tensor ln tensor, let's say out. Does it return tensor? Yes, it does, and we need to make changes in the header file as well. So LayerNorm forward, we should take a, and what? Let's say x. Let's assume x is our MHA output, right? Okay, and now printf shape out, and this is tensor shape 2D of out. Ooh, we haven't randomized. Let's just randomize over here, and okay, ready for the errors. Yes, we are. Alright, so let's just ensure that we receive as less number of errors as we can. So LayerNorm.h, and this has create new arena, takes features, and it returns what? It returns LayerNorm, yeah, and then forward method. I think this is forward new, I guess. ln.c forward. Okay, not new. It's actually, we are correct in the header file, but we need to, yeah, this is also fine. And norm.h, this is also fine. Yeah, looks fine at least. And now inside this run file, tensor arena and ln.c as well. Boom. Implicit declaration, create new. Where is new? ln dot. Yeah. Right. So if we search new, okay, ln.c new, create new. This is our new actually, and LayerNorm.h. Yeah, this is new. Okay. Tensor.c, we should use LayerNorm new. Yes. Some typo. LayerNorm create new. Did you mean LayerNorm create new? Still error. Tensor 787. Again, typo. Okay, what is this X? LayerNorm forward. Okay. $7.89. So we have A, we have ln as well. This is ln1. Okay, so where's the output? Okay, let's see if it works. Tensor, what is this? Forward. Really? C32, and we haven't put a comma over here. Boom! Issues, errors, expected. All of them are expected. That's what we need to solve. Simplistic declaration of function tensor square. Did you mean tensor square root? Yes. So let's see. Do we have tensor over here? Yes, we have tensor. Forward. What's wrong? Tensor mean. And tensor square. Do we have tensor square for a function? Yes, we have. What it takes is... Okay, so yeah, there is something wrong here. So tensor square, you know what it does? Basically, it takes the square element wise, but we have passed two different tensors over here. But I've done, since I've already written this function, and I knew that this is wrong. I said that I was lazy enough. I said that I'll resolve this later. And what did I do? I passed the two same tensors at the same time, like a equals b, and this will do exactly the same thing. But I think there's something wrong with this function, and let's just see what is wrong. So we have tensor implicit declaration. Did you mean tensor add? Okay, let's just see tensor div. It's there. Square, it's also there. Okay, LayerNorm forward implicit declaration. Tensor, did you mean tensor square? No. Okay, how did I call it? Let's just see. Tensor square div, that's right. Tensor shape div. Does it reach still here? Let me just check. It doesn't compile. Okay, so implicit declaration flow from tensor. Okay, so what is the type of norm.edge? What is var over here? Oh, what is float? It should be tensor. And we need to create that tensor as well. Boom. And rest is fine. And let's just fix this problem first. So inside our layer norm, which is here, yeah, forward ln Okay, so let's just go into the create function and what does create do over here? So okay, so I think the problem is it says that you have var as a floating point number in your structure. You need to change that first thing because we are assigning a tensor to a floating point number, which is completely wrong. So we need to make changes. That's the whole purpose of this thing. And the other thing is it does we haven't initialized anywhere beta, gamma, and variance, and we're just assigning them values. So we need to specify, we need to check first that whether in the create function have we actually initiated these or not. So this is layer norm create new, and let's see what it does. So it has features, it has dimensions, it has everything. Beta x hat null, and these two are null. So instead of null, can we do one thing? So this is right. This will be assigned. No worries with the beta and gamma. The only problem is right here, and let's just do one thing. Uh, yeah. So what we can do is here is let's just try this. If it works, so this should be x hat, and we'll assign random values to this, and this is var, and we will assign random values to these as well. And let's just uh, layer norm.h, and now we have this as a tensor over here. Perfect. Let's see what happens now. Okay, so it doesn't implicit declaration. Okay, let's forget about these. What is the actual error? Too few arguments and gamma. Yeah, we haven't passed arena, I think. So if I go to tensor.c and we need to pass arena, or ln.c. Okay. This should be arena as well. Okay, so tensor add arena. Tensor also takes arena. Yeah. Yeah. All right. So tensor add. Oh, this is wrong. This is wrong. This is wrong. Okay, let's just do one thing. So tensor y add will be something like this. Y, or I can wrap this here as well. So tensor add. Mm, ln beta, and then we need to pass arena here as well. Will this work? Let us see. Tensor. Okay. All right. Let's just see if this works. Too few arguments. Okay, let's just write them. Okay. Let's just confirm. Is it the right way of calling wrapping functions in C? Forward. Okay. All right. So let's just check this. Okay, is this correct in C? Syntactically incorrect. Yeah, so this was I thought I should create different steps. So C is not really chain friendly. Yeah, so we cannot chain the functions like we do in other languages. So let's just do this, no worries. So tensor y ahead would be is going to be tensor forward a ln gamma and out, and tensor y is going to be tensor add arena y head like so. This is not float. Strange. 105 float. Oops. Yeah, we don't need this. We don't need this. We'll write this later. Redefinition. Yeah, that's correct. That's absolutely correct. We have redefined this. Should not redefine this because we've already defined it over here. And so let's just do this. How about this? Yeah, just y assign this. Boom, another issue. Tensor shape. Yeah, tensor shape 2D is the right call, I guess. We've changed everything. We're changing everything, right? Yeah, this should be okay. Let's just don't need to print this now. Segmentation fall, our best friend. So we're trying to use some memory which we haven't defined either, or we're trying to just accessing the memory index which goes out of the bound, right? All right. So what is wrong here? Okay. Okay, so declaration of tensor squared union tensor square root. From integer pointer. Okay, so initialization of tensor pointer. Alright, let's just check the header files. Tensor.h. Damn. We haven't defined the function over here. It's only backward. So we need to add it up over here. And really, how can I miss it? Square. Okay. Yeah, nothing. Okay, so let's just add it over here. So we have tensor square. It's gonna take arena tensor b, and what else? Tensor dev also takes a and b, and let's see what happens now. Okay, something is wrong. So incompatible type tensor square arena. Oh, oh man, arena pointer. Boom! Again, we stumbled upon seg fault, but we will fix it. And one clue that we receive is shapes mismatched. Right here, 402. So, move forward. A shape 1, columns of first equals rows of second failed. Tensor C, tensor move forward. Okay, something wrong is here. Dot C, where do we use this? Tensor matmul forward. There is something wrong. Something is wrong here. Do we use this function anywhere else in this for function? Tensor matmul. Okay, so how about tensor matmul only? Okay, this is the only time we are using it, right? So have we got till here? Tensor shape to d out. Yeah, final part is not working. Why it's not working? We're close. We're close. We're about to do this. Okay, inshallah, we will do this. Uh, forward. Uh, ln.c. Gamma and out. Are you serious? I think we need to take the transpose here, right? Yeah. So let's just do this. Tensor transpose. Will this work? I think it should. I think it should, like, really. Let's see. Let's see what happens. Boom. Still it doesn't work. So I think shapes mismatch. Shapes mismatch. Shapes mismatch. Why? Tensor shape. What? Shape out. And what else? And this is again. And just do this. Gamma shape and out shape mismatch. Okay, let's see what are the shapes. 132 and 1632. And we transpose this thing. Okay, 132 and 1632. This becomes 3216. Can we do one more thing? Can we do one more thing? Like if I do something like this, uh, tensor out transpose is equals to tensor transpose out. Do we need to build a computation graph for this or not? This is exactly the same thing. Okay, so tensor shape 2D out transpose and this. So yeah, let's see if shape matches now. This should work, man. Tensor add. Okay. Do we need to take transpose again? Yes, we need to. Yes, we need to. Yes, we need to for addition as well. And let's just search shape. Yes, we need to. Yes, we need to. Y hat and beta. So this is a rough code. This is not at all optimized. We'll optimize this later. This is for beta tensor. Or should we take the transpose back again? Uh, no, failed again. Tensor add shape 0. Ooh, yeah. We need to expand columns or something. This is interesting. Like, I need to expand columns. Let's just see now. Okay. Div. Okay, let's print all the shapes over here. So, okay, so tensor shape of out first thing. Tensor shape 2D out, and same we're gonna do with shape y hat. This is y hat. Shape gamma and shape beta, we know them, right? Shape out is this. Shape y hat. What's wrong with y hat? So how do you find y hat? Wait a second. Shape out is 1632, shape y hat is 116. Why? Alright, so alright, so what is LayerNorm forward? Okay, so shape doesn't match, and you know what the problem is? I think there's something wrong with this line. Let me do something over here. So Yeah. So you know what the problem is? This is actually not matmul operation. This is a scaling operation, right? So we're using the wrong function, and we need to write another function called tensor matmul, tensor scaling. So let's just quickly write this. Tensor it's gonna take arena a tensor x tensor y, and it's gonna do exact same things. So tensor square is right here, so I just need to copy this entire thing and we'll change the logic there. Tensor scaling, let's put them all here, and blah blah blah. These have same shape, everything will work just fine. And this is okay. Let's use the same convention. A and B, everything is fine till here, and this is actually tensor. Tensor scaling backward, and what this will do is this. Let's just remove this line. What this will do is it will element wise multiply. Yeah, so I think it's exactly the same method we've already written, right? So can we use this? Yeah, okay, we'll fix square. That's wrong, this one is correct, right? Okay, so yeah, so I'll tell you later what's happening over here. So a square is something you go element wise and take the square of every single item, right? This is a square. So I've passed two matrices over here, so I've done a kind of trick here. So I'm passing two different matrices, which actually worked fine for me for this scaling function, right? And yeah, this is fine. So tensor scaling, and let's just add it over here as well. We'll see backpass later. And tensor scaling backward, right? I'll implement this later and just go ahead and register it over here as well. Tensor.h, and this is like what? Tensor tensor uh, tensor, yeah, exact same thing. So instead of this matmul, where's matmul? This is tensor scaling gamma, and we don't need transpose now. We need out and out and out and out. No, we don't need the transpose over here either. And what should this work? Not receiving the same error. What is wrong? Let's just see. Okay. Let's do one thing. You can do a hack over here, and let me just print the shapes. So we have gamma shape 132 and output shape, which is x hat shape 16 cross 32, right? And this is not suitable for scaling. And what we can do is, let's do one thing. Scaling. So tensor scaling. Yeah. So can we do something like this? Uh, so tensor gamma equals, and then can tensor gamma expanded would be, so now we have only one row and we have feature number of times columns, and we need to take the transpose. So we have feature number of times rows and one columns, and we have already written such function in which we can expand the columns, right? So I'm taking the transpose to expand the columns to match the dimensions, right? So it would be tensor expand columns, and it's going to take a, and it's going to take what else, let's just see. So tensor.h tensor expand columns output shape, yeah, okay. And this is actually gamma transpose, and the columns would be out shape one columns of this, and this is gamma exp, and this would be our scaling, and then yeah, we need to match this shape as well, but let's just see where does it break now. I mean, the broadcasting is the most difficult thing. Gamma, this should be ln dot gamma. Okay, shape 2D. um all right, so this is ln gamma, let's see if it works. What is wrong now, dude? Huh? ln gamma has no member, really? Yeah, that's right, this is actually gamma exp, gamma shape 132. Should be 0. Yeah, gamma exponent shape, tensor scaling, and this should be, oh, okay. So if I do something like this, let's see if this works. uh boom, and gamma exp, after expanding columns, should we take the transpose again? Let's see, let's see. Yeah, it worked. Okay, now we have issues with tensor add and tensor add. Okay, so we are getting the shape of y hat. That's great. That's great. Shape 2D thing, and we're good till here. And okay, this is working fine. And this is our ln beta, and we need to do the exact same things with beta as well. Mm, beta exp beta and beta exp. Okay, so shape 2D beta exp. Man, this should not be ln beta. I'm frustrated now. Hopefully this is the last change. Where's our shape? We need to return this as well. Add. Should we check the shapes? Okay, let's just try. Dude, still shape mismatch. Shape 2D. Print F. Okay, so beta transpose and y out shape 1. Okay, so y hat shape, and let's see, beta exp expanded. 3216, really? Okay. Oh man. Okay, this is not working for some reason, and let's make it work. Transpose, that's fine. And okay, so do we need to like take transpose again? Yeah, it seems like from the error. Shape 2D, okay. Um, we'll optimize this later, but right now just, somehow produce our required results. What are we returning over here? I'm stoned right now. Feels like. Dude! We got it finally. And can we print this as well? I think we should. Tensor shape, what? Out. And this is 2D tensor. Just overexcitement, just overexcited. Okay, let's see. Really? Uh, oh man, tensor get 2D. Alright, so we are getting some results. Shapes, we are able to find the shapes. We got our computation correctly, but there's still uh, something that needs to be fixed. So we fixed the shapes, we've resolved the issues, we've integrated the code well, and right now it's just a matter of, seeing what actually is wrong with the computation. And I'll see you in the next one.